Guys, I hope my screen is visible.
Yes, it is.
Let us continue. So, yeah, I know it's been a long time since we had Diwali weekend and everything. But did you guys got a chance to go through the things that we discussed? If you have any questions now, you can ask, right? Because we will be moving one step forward. Yeah. So you guys can let me know if you have any doubts or anything that you want me to repeat here. Okay, so guys, I hope everyone is clear with this, right? Can you give me a confirmation? The execution context, it gets deleted, all those things, right? You guys are able to recall that, everyone? Okay, cool. So now what we'll do is we'll try to talk about a little bit of asynchronous behavior. So we know that JavaScript is a synchronous single-threaded language. That means it can do only one task at a time because it has only one call stack, right? But if that is the case, let's say if you go to this, let's go to Unsplash. So tell me one thing, guys. Let's observe how the images load. Okay, so you can see that are they getting loaded one by one, or they are kind of getting loaded together? If it was a synchronous language, then it would have loaded the image one by one, right? Because it was doing one task at a time. But you can see here that it's getting loaded together, right? So how these things are happening? Synchronous JavaScript behavior, you cannot do nothing much in that, right? Because it is synchronous, it is uh, you can see it would be slow, and there could be some blocking code, right? Let's say if a code is running for 1 second, then the whole call stack would be blocked, right? So that's why we have asynchronous programming in JavaScript. But what is the default behavior of JavaScript, guys? It is synchronous and single threaded in nature, right? So, and that's the reason, right? Because let's say if you are, let me create a folder here. Okay, so let's say that you're fetching some data from the API, you're fetching the data, and that is taking 5 seconds. So that would mean what? That means that your all of your code, all of the other code will be stopped, right? Because call stack is busy. So entire browser will freeze. The UI will stop responding. The button will not work. Nothing will work, right? So that is the reason why asynchronous programming came into picture. So it allows for, let's say, for long running task to happen in background, right? Now this is asynchronous. This does not mean parallel. So parallel means if you are having different threads, right? So you are not having different threads here. Like Java is a multi-threaded, right? You do not have different threads here. You have only a single thread, but you can do something in the background. So that is asynchronous. Okay. How it will do it, we will see. But this is the core idea. Is it making sense, guys? Why do we have asynchronous programming in JavaScript? So the basic idea, if I would say, is that you can say that you should not wait, right? The ideal situation should be that you should not wait for slow task or long running task. Instead continue executing other code, and when the slow task finishes, come back and handle its result. So only this could be possible, right, in a single thread. So what we are doing is we are saying that, okay, so if you only have one task or one hand, so let's execute whatever we can quickly. If some slow task is running, we can push that in the background. It will keep on running. It will keep on running. So once the stack becomes empty, or you can say once the slow task is finished, we can execute that quickly, or we can handle that result, right? Okay, so let us try to understand. So let's take an example. Let's say I would do something like this, and then I would use a set timeout. So before going that, we discussed about functions, right? So you can do something like that in JavaScript. Let's say I'm doing function X and I do console.log 10, and I say function Y, and I would print console.log 20, and I can say function X. So what will be the result for this? What will be the result for this, guys? It will be just it will be just 10, right? Because we are just calling function X, right? But you can do something like this. You can pass this function as a callback. You can pass this as an argument, and then you can extract that. You can say callback and or CB or whatever. It is just a parameter, and we can execute it after some time as well. So this pattern is called as a callback pattern. Now what is happening? First X is called. You pass the Y as a reference to it, and then it prints console.log, and the callback function, the reference of Y is called, and it will execute Y. It will go inside Y, and it will print 20, right? So that's why we see 10 and 20 here. This part is clear, guys? Callback. This is called as a callback. Okay. All right, guys. So now, using this, what we can do is we can say, let's say console.log hello world, and we can use a timer function. Let's say set timeout, and inside this we can pass another function, or we can directly use this anonymous function. So this is called as anonymous function without any name. You can use it for passing as the callbacks, but you cannot use that directly, because then directly you would have to provide a function name. But you can pass them in the callback. So it could be this function, or it could be arrow function, it could be normal function, right? So this set timeout takes two arguments. One is the function that you want to execute, and second is the timer in milliseconds. So I'm saying 1000 milliseconds. That means 1 second. Inside this function, I want to just say console.log timeout called, and here I can say console.log end. So this particular part, what it does, it will execute this function only when, see, set time out will run. It will only execute this function when the timer expires. So the timer is 1 second. So what do you think, guys, will be the output here? Does anyone know the output here? Considering that the JavaScript is okay, so Diksha is saying hello world end and timeout call. Yeah, that is correct. But if it was synchronous, guys, right, then it would have taken 1 second and the code, all the call stack would have been blocked, right? So yeah, so the output is correct. It would be hello world and then end and then timeout called, right? Now, what if I change the timer to 0 milliseconds or 0 seconds? Then what? Then what do you think will be the output?
Still will be the same. Output will be the same.
Yeah, so that output will be the same. But why that is happening, guys, and how that is happening? That is the thing that we need to understand. Okay. Now, first of all, let's try to understand this part, and then we'll go to the 0 milliseconds. So this part of piece of code is synchronous. This part of code is synchronous. This part of code is asynchronous, right? So how this works is, let us have a comparison. So let's go here. Yeah, let's paste it here. So we know that, guys, we have execution stack. You can create it however you want. Let's say that this is our execution stack, and the below part is our browser, right? And let's also create a call stack. So this is our call stack, and this is our web browser, guys. Now it turns out that web browser is a very powerful, remarkable, you can say, creation, right? And why I'm saying that is because a lot of things JavaScript borrows from the web browser rather than on its own. So JavaScript only has a single uh, threaded call stack, right? And it has JavaScript engine that is written on C++. But that is just for executing or compiling the JavaScript code, okay? Or interpreting, because it's an interpreted language, or you can say just in time. We will discuss that sometime later. But we have the JavaScript engine and we have the call stack, right? That's it. Very important thing that JavaScript does, it uses browser features and it enhances the functionality, and that's how we can build the applications. So web browser is really powerful. Now why I'm saying web browser is powerful, because it has lots of things. It has this timer has a label set timeout. You also have set interval, right, to run a code on particular intervals. So we can consider it to be a timer label. So set timeout is a part of this. Now web browser contains something called as web APIs, right? So these are not part of JavaScript. Although we are writing in JavaScript, this is not a part of JavaScript. In fact, this console that you see, right, this console.log that you see is also a part of web APIs. And web APIs are just APIs that are provided by the browser so that we can use the browser features using our JavaScript. Now, similarly, whatever JavaScript does is, right, it takes help from the web browser. So timer, I told you, the one we are using. Console also we have used, right? It's not a JavaScript feature, it's a browser feature. Another thing is that if you want to fetch the data from the API or from a server, right? So then you will use a fetch method. So it talks to the server. So it's a fetch label, right? Then we also have a couple of more things. So we have a lot of things, right? I'm talking about the most common ones. Then you can use a storage API. So storage, there are a lot of storages. There are cookies, there are local storage, session storage. In fact, browser has its own database that is called as IndexedDB, right? So it has a lot of web APIs for your different use cases. So we talked about timer, console, fetch. It has storage capabilities. Then what else, guys? See, there are a lot of things you can uh, integrate Bluetooth. You can integrate your controllers, right? So let me tell you. So if you go here, you can search for JavaScript or browser, web APIs, and Mozilla Firefox, and you can see there are a lot of APIs, right? Hundreds of APIs that you can use to make your web applications. You can see barcode API, badging, battery status, Bluetooth, broadcast, background fetch that we talked about now, right? Fetch API that talks to the server and bring the data. All these are basically the APIs. File system API, geolocation API, gamepad, HTML DOM, history API to get the history of the browser, right, where the user has navigated, IndexedDB, idle detection. All these things you can use for your different use cases. So this list is very powerful, guys. I'm sharing this link. Whenever you want to add any feature, right, just quickly go to this and see that if you have a web API to do that. Even if you want to have some text to speech integration with AI or anything, you can use the browser's web API, right? The speech API, speech recognition API. So all these things are part of web APIs that enables JavaScript to build all these cool front-end applications, right? Now the thing is that we know how this will work. Okay, so let's say that what are the in how many phases JavaScript run? We know that two phases, and we know that this GEC will run, right? That is global execution context. So the execution context is divided into how many components, guys? This execution context will be divided into how many components?
Component.
Two. What are they?
Memory and code component.
Okay. So you can draw it anywhere. You can draw memory code here. It's up to you. Like let's say code here and let's say memory here. So you guys know the technical terms for it, right? Code is thread of execution. Memory is variable environment. Okay. So now let's do that, right? So let's say we have first line. So we don't have any variables or anything, right? So the first line will be executed. That is console.log hello world, right? So tell me, guys, what will happen here? We just see this, and the console prints hello world, right? And here we have the global execution context. Or you can say that it's always running, right? So let's keep it on top. The global execution context is always running. Okay, so we see that first this line will go here. It gets executed because there is nothing in the memory part, right? And we see hello world here. Now, what is the second line that will get executed, guys, after this console.log hello world? What is the second line that will get executed? What do you think? See, JavaScript will execute one task at a time, right? And synchronous, that means top and bottom. So what is the next line of code that will be executed after this hello world? What do you think?
Set timeout.
Okay, set timeout. Yeah, exactly. So this set timeout now will be called, right? Now, as soon as you trigger the set timeout, okay, we are accessing which feature, let's say callback and some timer. So we are accessing which feature of the web browser, which web API, timer, right?
Yes.
So you can say that the callback would come here. Let's say the callback is now registered here, right? And the timer that is expected here is 1 second for 1 second, right? Okay, so let's say at 0 milliseconds. See, timer is running, right? Timer is running. So at 0 milliseconds, we ran this code, right? So JavaScript is very fast. Just for understanding, we are saying that okay, at 0 point, or let's say just to understand the difference, we can say that at 10 milliseconds, it ran this piece of code, right? Now it got executed. So when it got executed, the timer is running for how long? For 1 second. So JavaScript, always remember, JavaScript will not wait for anything, right? So it will quickly execute the next line. So since this part of the job is done, what is the next line to be called? Console.log end, right? So it quickly executes this line, let's say at 10 milliseconds, and or 12 or whatever, or you can just say 0 only, right? Because it is very fast. So at 0 milliseconds, all these things are happening, right? And this went here, then this went here, it got executed, then this went here, and we got end as the output. Now it will wait, right? Now the call stack is empty. It will wait. It will wait for how long? It will wait for 1,000 milliseconds or 1 second. So when 1,000 milliseconds has expired, this callback function will run. It will get executed. It will come back to the call stack, and this function was doing nothing but set timeout called. Okay, so this is how you see the working of it. Right? Is it making sense, guys? The basic part. There are a couple of rules. I'll come to that part, but this part is clear, right? That we have a web browser and something is running in the background, right? And once the background is done, once all the part is done, once the call stack is empty, the callback will come, it will get executed, and then you see the output like this. Okay, so this is the basic thing. Now, what if I change it a little bit? Let's say that I change the timer to 0, and you can say that we say function, and let's say run for 1 second, and assume that this is synchronous. This is synchronous code that's running for 1 second, and it prints something like, let's say, running or whatever, right? And then I execute this piece of code. Okay, so assume this function runs for 1 second. You can also add a date time and you can create a dummy function, but assume that this function runs for 1 second. So what do you think would be the output, guys? Now it is getting confusing, right? So if you want to check this out,
So
you can do this.
actually,
Uh,
first it will print the hello world, then
okay,
it will be print the running, then it will be sorry. First it will print the hello world, then running, and then end, then timeout called.
okay. What about others? This is correct, right? But the people who are new to this, guys, do you think is it confusing or not? Just by reading at the code, you cannot guess the output, right? Okay, so it's not confusing as it's confusing because you don't know the rules, right? Since see, the limitation that we have is just that we only have one call stack. JavaScript has just one call stack, right? So let us now try to understand what all the rules we have, and then I'll tell you, right, how this will work. Okay, so let's copy this, just paste it here. So let's say that we have our web browser and we have our web APIs, and we have couple of web APIs. Okay, and we know that we have the memory and code part. And we all know that we also, so these are the pieces, guys, that we are working with, and behind the scenes this happens. So we'll try to understand what all the rules are there, right? And then we have the call stack, and we know that the global will always be running. And let's say that we have console here, and yeah, that's it. So what will happen, guys? Let's go this function. What will happen quickly? What will happen initially? No variables, only one function, right? So we can say that this run for 1 second will be stored as a function block. So I'm just denoting it like this, right? Then there is no memory to be assigned to, right? So JavaScript move to the second phase. The second phase is that it is running console.log hello world, right? So we quickly get that printed. What is the second thing that will happen? What is the second line that will run, guys? And we are assuming that this happened in 0 milliseconds. What is the second thing that should get executed? quickly. Sorry?
Set timeout.
Yeah, set timeout, because here the function calling is taking place. Great. So set timeout is getting called, and JavaScript is very fast, right? So this is also at 0 milliseconds. Now what will happen, guys? As soon as this function is called, what will happen? What will happen? This is executing which web API?
Timer.
Timer web API. So the callback will get registered here, right? And again, we are at the 0 milliseconds. So the timer has expired or not, guys? The timer is expired or not? The timer is already expired because it is a 0. Now, since the timer is expired, why the output is coming like this? That is the thing that we are trying to understand. Now, how it is behaving is, I told you guys, right? JavaScript will wait for nothing. First, this console.log was executed. Then set timeout came into call stack. It got executed. It registered the callback in the timer web API, 0 milliseconds. But guys, after this line, was the whole program finished, or there was the next speed of code that would run? JavaScript will wait for nothing, right? JavaScript will wait for nothing. It quickly executes whatever it sees. So after line number this, what it will see?
Console log and
No, it will see this run for 1 second, right?
yes.
So now you can see that why, and see why there is a reason. See, callback is staying as it is, right? So the call stack is not empty. If the call stack is not empty, how it will bring back the function, right? So that's why there is something called as this queue, callback queue. And even though you see the timer has expired, this callback after 0 seconds would come and get registered here. But is the call stack empty, guys? That is my question. Is the call stack empty? No, because it has this synchronous piece of code that it has to run. And this piece of code will run for how long?
0 millisecond.
No, this piece of code will run for how long? We know that an execution context will be created, right? So this piece of code will run for how long? What is the job of this function? What are we assuming? That it will run for 1 second,
Yes.
right? And we see running here. But now what is the time? 1000 milliseconds has expired. So we can assume something like 1001 milliseconds. At 1001 millisecond, guys, again, this execution context job is done. It will get deleted. But now we ask that question again. Is the call stack empty after this code? Is the call stack empty? Or it has the work to do?
That execute next line.
Exactly. It's still not empty. It has to execute this line. So then it executes this line. Meanwhile, what is happening to this callback? Even though the time expires, after expiry, it is waiting in the callback queue. Why it is waiting, guys? What is the reason? Why it is waiting? Why it is waiting? What is the reason? What is the core reason? Why it's waiting? Here it's written, guys. Everything is written here. It is synchronous, single-threaded language. It can only execute one task at a time. So it's already executing a task and it's a single-threaded, so it cannot take another task. That's why we have these rules, right? That's why we have these rules. So again, this end gets executed. and end gets printed here. And now we can see that at 1002 milliseconds. Now we ask that question again, is the call stack empty or not? What do you think, guys? Finally, when all of this code ran, is the call stack empty or not empty?
It's empty.
Empty. So then what will happen? How do this particular piece of the how what is the way to interact here, right? So there is a loop that keeps on running. It's literally a loop. It every time whenever something ran, it will just check if the call stack is empty or not, right? So there is a loop. It keeps on running. It will just check. It will keep on running. It will keep on running. It will keep on running. It's just a loop. It will just check. Its only job is to check if the call stack is empty or not empty. As soon as the call stack is empty, we see hello world running and end as the output. Then what will happen? Then automatically this function finally will be moved here, and JavaScript will assign parentheses to it. So it will be called, its execution context will be created. All those things will happen. But ultimately, what this part is doing at 1002 milliseconds, this callback is called, its execution context would be created, and finally you would see the output as timeout call. Now that is the confusion, guys, and that's why these type of things are asked again and again in the interviews, because even though you expected it to run at 0 milliseconds, because we gave the time as 0 milliseconds, ultimately it is running for approximately more than 1 second. It's getting executed after 1 second. And why? Because all of the code took that much time to get executed in the call stack. The call stack was busy. So we know all those things, right? In the end, again, the call stack will become empty. So one way to think of is that if you have some asynchronous code or some code that is related to web API or that is asynchronous, it will always run after all of the synchronous code gets executed. And why? This is how the rules, right? So this is a queue. It can contain multiple callbacks. And we know that only when the call stack will be empty, because it's only has one hand, right? You can consider it to be a waiter, and the waiter, there's only one waiter, right? So first it will go order by order. So that is the thing. So is it making sense, guys? Everyone, any questions here?
So
That's why we
callback
have these
take
rules. Sorry, one by one.
so callback stick will take all the code inside it, or it will be only functions.
See, all which code? See, all this is a part of memory, right? This web browser and JavaScript memory are in sync. So this CB is already in the memory. It will just attach the parentheses and it will call that. That's it. But this function is waiting in the queue to be executed.
No, I'm not getting why after run for 1 second callback is not empty.
No, callback or call stack.
Call stick, sorry.
So that's why I'm saying, na, see, this has moved to background. This is a part of web browser, right? So when set timeout was called, this set timeout call was to just register this function in the web API. So this part was done, right? Now the timer is running here, but JavaScript will wait for nothing. It will quickly execute next line. So the next line was this line, right? Next line was this line. Then next line was this line. Until here, the code, the call stack was busy, right? Getting this point? It has the job to do, right? It has to execute all of the things. That is the purpose. If you are using something that is asynchronous, if you are using something asynchronous, that is this web APIs, not everything is asynchronous, but some part is asynchronous, like fetch is asynchronous, timer is asynchronous. So that's how the behavior is, right? You moved it to the background. Even though the timer expired at 0 milliseconds, the call stack was working continuously until the end, because call stack or JavaScript will wait for nothing, right? It will just execute the next line, the next line, the next line until the end. So that's why it sits on the queue, and that's why this event loop that keeps on running, it just checks that, hey, that call stack, are you empty? If the call stack is empty, then it will move this part to this part. Is it getting is it making sense now?
Yes.
Sorry.
Yes. Thank you.
Yeah. Any other questions?
Sir, so it means there is no guarantee the time will be called at the exact given time.
Exactly. It depends on the code, right? Because see, it's a single thread. How would you
So
know that how much time your code is taking?
so it means if I set the timer to the for the 1000 milliseconds, so that time will be the minimum.
No, what do you mean by minimum?
Minimum in a sense, at least it will be wait for a 1000 milliseconds, but after that it can invoke any time when the stack is free.
No, it's not about minimum. See, here we took an example that this function is running for 1 second. If this function was running for 500 milliseconds, then it would be 500.
So my question is, so if I set the 500 millisecond, it means the 500 millisecond will be the minimum wait time. Apart from the 500, it can take any time when it's wait for the stack to
No,
empty.
no. There is no minimum time. The time actually, see, why we are taking this time? We are taking this time to understand, right, how it's working. This time will depend on the code. It could be that it is taking 50 milliseconds. It could be it is taking 500 milliseconds. It could be it is taking 5 seconds. It could be it is taking 10 seconds.
No,
Getting my point?
I'm talking about the timeout which set with the set timeout function
So,
callback.
so that's what I'm saying. Now, let's say that you are running it at 0 seconds, okay?
So if I
And
running for the suppose 100 second, the timeouts thing. So it means that it will be wait to the 100 second, and after that it can invoke any time when it's the stack is free.
so it will be a same situation, right? See, it will depend on the code. So let's say this was running for 100 milliseconds, right? Getting my point? Now, again, same thing. Up till here, is the call stack empty or not? It's not empty, so it will keep on running. Now, between this, somewhere that this time will expire, right? So when this time is expired, then the callback will move to the callback queue. So there could be a cases where you have two set timeouts.
Okay.
So that will depend on the time. So that will come under the queue. Whichever one expires, that will come under the queue. That's why I'm saying it depends on the code. This is something that we have just taken for reference to understand, right? Just we have taken some arbitrary values in order to understand the flow, basically how this synchronous and asynchronous piece is working. Getting my point?
Yes, sir.
Okay. So there are a lot of pieces, guys. So now we have introduced new pieces. The new pieces is the callback queue and the event loop. And that's why these rules are necessary, guys. Why these rules are necessary? Because again, the main thing is that it cannot do multiple tasks at a time, right? So that's what we started from, and that's where we ended, because it cannot do more than one task at a time. So there should be some rules, and these are the rules that it will follow. Any other questions, guys?
Sahil, if we have set timeout function, inside
Hmm.
that we have one more set timeout function which is having less timeout than its parent. Then how callback queue will like it will based on the like time it is like minimum or it will be one by one.
No. It will be if it will do the same procedure. So this will run the parent. Okay. Then that will go again here. Then second one will get registered here. Then when the second timers expire, it will again come to the callback. So it's a loop. Even if it's nested, it will only execute the parent. Once the parent is executed, it will run that child set timeout here, and then this loop will keep on going, right? It's not like it will take the minimum of 2.
Okay.
Okay, so you can also visualize. So you can see this. I'll send you this loop video. Guys, check this out. This is like this one. Just watch this video. It will make much more sense. Okay. Let me share this link. So this guy created this website as well. And you can visualize it here. So in order to make that run for 1 second, what we can do is we can say that start, and we can say date dot now. It will give us the timestamp. Okay, that will give us seconds timestamp. So what do I mean by that? If you go here and just call this, you get this in like milliseconds. Okay. So what we can do is we can say we'll run the loop while the difference between this new date dot now and the one that we have stored in the variable is less than 1000. So it will keep on running that loop. That loop will only end when the time expires like 1000 seconds. It will just keep on running. I'm putting a comment, keep on running. And after that, we will execute this line. Okay. So this will take the same, it will take 1 second. So it's running. And you can say 2 seconds. So this will run for 2 seconds. Now let's copy this. Let's paste it here and let's see the flow, right? So you can see the first thing will be printed console.hello, then timer, and then date dot now running for 1 second. It is running. It is running. In the callback queue, you see that it is already there, right? In the end, once the call stack is empty, it prints the timeout, right? Let me rerun to see that, right? First, hello world, then set timeout gets registered, then run for seconds. JavaScript waits for nothing, right? It keeps on executing. Once that run for 1 second expires, it's done. Then anonymous will go here. This function will go here, and then it executes. Web API callback, and then call stack. Is it making sense now, everyone?
Yes.
So you can try out this as well. This is very important piece, guys, right? So I can only see 2 people replying. What about others? Benazir, Srilekha, Raksha, Nazir, Siddesh, Naren Thiran. What about you guys?
Yes, it's clear.
Okay, Usha. Okay. So another important thing is even the DOM part that we use, right? The DOM events that we will use, that will also come under that. Event listeners on mouse click, all those things. And all I've given you the list, right? So you know all those web APIs. Right? But another important question, guys, if you see the Unsplash screen, right, that I show you, so it feels like parallel, but is it actually parallel?
No.
Right? So if interviewer asks you this kind of question, right, what is the difference between the parallel or asynchronous versus parallel, anything, then what would you say? What is your understanding out of this? Come on, guys, every one of you knows the answer. What is the actual
Yeah,
thing that is
parallel
happening that we
means
have seen?
the running two tasks at the same time.
Yeah, so it feels parallel, but it's not parallel, right? Then what it is?
Yeah, because it's waiting for the timeout and once and the queue to the clear. Once the queue is clear, then it will be pushed to the stack and it will be executed. So it's not the parallel.
Yeah, so you can just say that even though it feels parallel, but in reality, it's just running later when the stack is empty, right?
Yes.
That's the main idea. It will just run later. That's it. But it's running in the background. The call stack is free. Since the call stack is free, the rest of the code quickly executes, right? And since rest of the code quickly executes, that's why you see that JavaScript is fast, right? And that's why you do not see lag on the buttons or anything, because some of the tasks are running in parallel, like set timeout, like fetching the data from the APIs. All sorts of things are running in the background, and that's why call stack has the time to quickly execute whatever the synchronous code that is there. Okay, so yeah, that is one thing.
I have
Now, yeah,
uh,
yeah, sure.
yeah. Yeah, sometimes in our code, like when we are working at Angular side or something like that, set timeout like before another function calls, this function will be called. So we increase the time. Then that is like which scenario now in our case, whatever we have explained is like once the code everything gets executed, the callback will be called, right?
Yes, yes, it's the same thing. Angular is also built on top of JavaScript, right?
Yeah, but sometimes set timeout that method will be called before another method call, so we increase the time, right?
Hmm. Yeah, it depends. If you have some events or anything, right, to be scheduled later. Let's say if the fetching the data or something else is taking more time than the set timeout, then those would be called later on. Or let's say if you have some what do we say, life cycle methods, right?
Yeah.
That also will be that also can run later on.
Okay.
So then you increase the time, right, to so that it can run a lot more later. That is what you're saying.
Yeah.
Yeah. So normally we should avoid using set timeout, right? You can use promises, or it depends, right? What is the actual requirement that you have? But
Oh,
ideally, we should avoid timers if they are not absolute necessary.
okay.
And you know why, right? Because they'll
Yeah.
never be accurate.
Yes.
And also, you keep on adding them in the memory, guys, right? So you can also clear the timeouts, but you should know when to do that. So it depends in Angular. When in React or in Vue, what we do is when the component gets unmounts, then we remove the timer, because then there is no need for the timer. Okay. Okay. Any other question? So let me tell you one more important thing, and yeah. So guys, we'll end the class like around 10:30 or something, because this is something that I want you to practice. Tomorrow we can take up some extended time, but let's also see one more important thing, right? So one more very important thing that I want to ask you is, the set timeout is taking what type of function? Like we call it as a callback, right? So one more important thing, are all callbacks asynchronous? What do you think? Are all callbacks asynchronous? This is what? This is synchronous or asynchronous?
Asynchronous.
Yeah. What about this? This was synchronous or asynchronous?
Synchronous.
This was synchronous, exactly. So one more important thing, not all callbacks are asynchronous. Some are synchronous and some are asynchronous. Okay. So earlier what happened was, we started with asynchronous programming. So the very first approach was using callbacks, right? So what are callbacks? We just saw the callback now, right? So let's say we create a function and assume that it gets some user data. And see, we are not directly fetching the data from the server, so we will assume that it takes some time. And you can use arrow function also. It's the same thing. And we can say that we want this function to be running for 1000 milliseconds, that is 1 second. And we can say console.log. Just assume that we fetched user data. Now we can say get user data. We can call this, and this is asynchronous, guys, right? So you know that this will run in the end. Now if I do something like display data, let's say we have a function display data, and we just say console.log display user data. Now can this display, guys, would this work? First of all, what do you think will be the output?
First display user data, then paste user.
So will this work? No,
Yes.
first you will fetch the data and then you will display the data, right? How you can display the data if you don't have the data at all? But what this will print out?
Display user data first and then fetch the user data.
But this is wrong. This is wrong, right?
Yes.
And now you know why, because behind the scenes, this piece of code is asynchronous and this piece of code is synchronous. All the synchronous part will get run first, and then this behavior is not expected. So what behavior we know now is that we can pass this as the callback. When we pass this as the callback, we can run it later sometime, right? So we can say callback, and we can say something like this. We can call the callback later on. And when we use callbacks, we can see that this is what we get. This is correct, right? Is it making sense? So this is one way of doing the job.
Yes.
Okay. So that is why we use earlier use callbacks here. Now there are two things, guys, right? There are two things here. Let me just revise it one more time. So let's say we create a function and let's say get user. We are just creating a dummy function and we can just say set timeout. Let's have a function and let's have a timer. Let's say 1 second. And we can just say console.log fetched user data. Now we also have a couple of more functions. Let's say we want to get users post. Let's say we are on a social website, right? And you want to get the users post as well. So we can say fetch posts. We can have another function. Let's say get comments. And same thing. Let's say that it is taking, all of them are taking 1 second. But if you want to change, you can assume that this is taking 1500. This is taking 2 seconds, whatever, right? Comments are taking more time. Fetch comments, right? So what should be the flow? What should be the flow? What should be the first thing that user should expect on the screen? What should be the first thing, guys? First, we should be able to get the user, right? Is it making sense? First, we'll get the user, then you will get the post, and then you will get the comments related to the post.
Yes.
But if you call them directly, you may not know the order, right? You may not know the order. If you call them just like this, will it work? It might not. Since it is taking time, it might work. But let's say if this was taking 1 second and this was taking 1.5 seconds, then this would come later on, right? Then this will fail. Let's say this is taking 500 milliseconds. So then what is the way, guys? What is the way that we can make this work? What is the thing that we saw just now? What is the pattern that we use? What is the pattern we will use?
Always.
Callbacks, exactly. So we can say that, okay, that we want a callback. We will
Before
call it.
that, can you run this code?
See, this we know, right? What is the reason of running? This we know that it will behave differently. I can show that, but this is not the way of writing the code. So you can say get user, then post, and then comments. So you can see you got fetch comments, then post, then user data. This is not expected, right? See, if you have the time, then this is taking 15 and this is taking 2000, then it might work. You see fetch user data, fetch post, and fetch comments. But we are simulating the API environment, guys. We are expecting this much time. We never know how much time it will take. It depends on the server, right? It will depend on the server. So that's why this is not a good pattern. So that's why we use callback, and we might want to call the callback after we fetch the user data. The same thing we can do here. The same thing we can do here. Same thing we can do here. Now what I can say get user, and I can say I can directly pass a function, guys. So this is also possible. So I can directly pass a function. Inside the function, I can say get posts. Now, if you are not passing the callback, that is fine, but this is how we can do. This is also a different way of writing. Ultimately, you are just passing this function as the callback, and this function in turn is calling get post. So now you will see that we get fetch user data and we get fetch post. The same thing we can do here as well. We can add one more callback function, and then we can call get comments. Similarly, we can add one more callback function, and we can say console.log all data fetched, all data fetched. Now when you will see that, you'll see that when I refresh, you will see that it works perfectly fine, that you get the user, then you get the post, then you get the comments, and then finally you get all data as fetched. But this, you can see, guys, a couple of things that is happening here, because we are just having 1, 2, 3 functions. What if there are series of steps, like in e-commerce, get user, get orders, go to checkout, go to payments, execute payments. Then you can see, guys, this code is becoming little tricky, right? It is becoming tricky. It is becoming hard to maintain. So this callback structure was used for asynchronous programming initially, but it has its own problems. So what are the problems? The problems are, it is hard to maintain. It is hard to maintain. Why? Because you can see that it is creating some kind of pyramid structure, and this structure, this maintainability issue, you can say that there is a term for it. It's called as callback hell. So it will create a callback hell. That is one of the major disadvantages of using the callbacks. And one more important thing is inversion of control. What do we mean by inversion of control? The inversion of control means that we are passing as a callback, and now let's say if an intern has used this callback couple of times anywhere inside the code, then it will call that function couple of times, and that is not expected. Why? Because you are giving this function's control to some other function, right? So that is very important to understand, that this get post or this get comments does not have the control on its own. You are giving the control to its parent, right? So for this part, you are giving the control to its parent, that is get user. And this get user, let's say if it is calling 100 times this callback for any other purpose, for any other use case, then that callback will also be called 100 times. Is it making sense? So two important things, guys: pyramid, this callback hell, and inversion of control. Right? You are giving the control back to its parent, so this function does not have the control on its own. And these two are the problems associated with asynchronous programming in callbacks.
Could you please explain inversion of control once?
See, are you calling this function on your own? Get post. It is depending on some other function, right?
Yes.
So that's the reason. It's not having a call of its own. There is no guarantee that it will be called only once.
Okay.
Getting my point? It could be that you are directly calling it here as a callback. So no matter how many times you call the get user, that particular function will be called. And the control, see, the control is moving, right? We only call one function, then then the series will get called. So these series are depending on the get user, right?
Yes.
What if get user was called for different reasons? What if the get user was only called for login purpose, or for just to get the details on the nav bar? You did not wanted to load the post or comments, right? Then what? So you are giving some sort of control to its parent, and that is a disadvantage. Guys, are you getting this point, right? Both the points: callback hell and inversion of control. Guys, waiting for a response.
Yes.
Yes.
Okay. So nested callbacks, hard to read, you can say anything, right? Inversion of control, callback hell, all those things. So then we have the concept of promises. So promises we would cover in depth, maybe tomorrow or next class, just to understand the flow or how it works. But basically what we can do is a function can return a promise. What is a promise? You will see promise is nothing but eventual state of something is happening, right? So if let's say you are fetching a data from the API, right? It's an eventual success or failure. What do I mean by that? At some point of time, that request can either be failed or it can be success. That's it. So let us try to convert this particular part into a promise. So how we can do that? We can say get user, and we can say return a new promise. So this will give us the promise object. Okay. And this promise takes a callback function. See, behind the scenes now, again, promise is using callbacks, right? But then we can write this piece of code inside this. And again, we are seeing that, okay, this fetch user data will be called for, let's say, 1.5 seconds. But now this get user will return what? It will return a promise. What is a promise? I'll tell you. So let's say we call this and we say console.log. So you can see that it returns a promise object, and this promise object gives you these states, guys. This, then, finally, catch, all these things. Okay. So let us worry about this later on. But this is how you convert a callback to a simple promise. Here you can see we are not passing this callback. We are just returning a promise. So similarly, we can do for the get post and get comments as well. And let me comment this part. So again, I'll say we can return new promise. It will take an object like this. We can convert it. And again, we can say we can return a new promise. It will take a callback function. Inside that, we will put this code. Now, a promise function, guys, it will take two things as the argument. So you can see that we are passing these functions, right? So this parameter would take two things. It will take a resolve and it will take a reject. Resolve means that a promise is resolved, or the promise is success, or it is completed. So there are only two states. A promise can either be resolved or it can either be rejected, right? So for now, we are assuming that it will always resolve. So we will not use reject at all. So what we can say, I can say after fetching the user data, let's say we resolve this function. We resolve this. we resolve this. Okay. Don't worry about this syntax. The syntax will cover in detail. But for now, we are trying to understand how people move from callbacks to promises, right? So now what we will do is we will just say get user, and we know that this is returning a promise, right? Now promise is giving us these methods. So this then will run always when a promise is resolved. This catch will run always when a promise is rejected. So when a promise is resolved, it will run dot then. When a promise is rejected, it will run catch. So we are currently on resolve. We are saying that, okay, it will resolve. So what we can say get user. We can call this out. And now we can use its thenable that is inbuilt in the promise object, right? And this dot then also takes a function. So we can say dot then. And if you want the data, you can get the data here in the callback, but you can see it's using a callback, right? So what we can say is we can say get user, and we can say dot then just get the ports. So you can use that, you can write it directly as well. So what does this mean, guys? This means that you are calling a function. This function get user is returning a promise. If the promise is resolved, if it is successful, then this dot then will run. And this dot then will ensure that the function runs only once. And that is the beauty of this, guys. It will only run once. It's basically, right, get the user, then what you want to do next. Okay, then you want to get the post, then again what do you want to do next, because this also returns a promise. So it's a chain that is happening. If you do console.log all of this, right, let's do console.log, you will see the returned part is also a promise. It's also promised. Fetch user data, fetch post, right? So again, you can add another dot then. You can say dot then. Then what you want to do? Then you want to just, let's say, get comments. Then next, what you want to do? You just want to console all data fetch, or you want to just display that the data has been fetched, right? So you can see all is happening correctly that we wanted, how we wanted, but this piece of code is more cleaner than this speed of code. Although behind the scenes promises are using callbacks, sometimes you don't even have to implement this because some web APIs like fetch and other APIs would return promise directly. So if you see the calling behavior, that is changing. And don't you think, guys, this piece of code is cleaner than this piece of code? That is the purpose of moving from callbacks to promises. Now it's fine. We will cover this promises, syntax, everything, right? But are you able to make sense out of this? Why this promise is more cleaner than the callback part? And this is a perfectly valid code now that you can write, even though we have async await, but you can write this out because this is a more cleaner approach than callbacks, right? The output is same as before, but this is much cleaner to write because we now have two things. We have the promise object, and this piece of code will ensure that it will only run that then once, right? Whenever this code gets finished, it will run it only once. Whenever this part is finished, it will run this only once. Whenever this part is finished, it will run this only once. So this solves the problem of callback hell and inversion of control. Is it clear, guys? I know you'll have questions like what is then, what is catch, that will cover, but is it making sense, right? That this syntax is more cleaner than this syntax. You will draw the diagrams, you'll understand how promises works, right? But for now, you are getting this problem solution, right? That is nothing but promise. Guys, is it making sense, others?
Yes, it is clear.
Only to Diksha. What about others? These things are very complicated, guys. We'll cover them in depth, but just trying to give you an overview of how things were before, how we have been using this, right? So there is one more way of doing it, that is async await. That is more clear approach, because the problem with .then is that sometimes it can also create a promise hell, right? If you're using multiple nested promise. So then what is the way? You can use async await. And async await is basically, again, guys, behind the scenes, async await will be using promises. So this piece of code will work. And promises behind the scenes are using callbacks, right? Ultimately, everything boils down to callbacks. That's why a lot of things are abstracted out from us. That's why this .then and catch would feel less intuitive, but it is easier to maintain, right? So we'll understand that. But how this async await will work, we can create a async function, and we can say async function, let's say fetch all data. And what we can do here, we can call this console.log fetch all data. And this, whenever, see, it's when it's a normal function, you will see its return value, right? You will see undefined, because we are not returning anything. But as soon as you add a async keyword to it, it becomes a function that returns a promise, right? It becomes a function that returns a promise, and there can be only two states of promise. A promise can either be resolved or it can be rejected. Only two things are there. If it's resolved, then will run. If it's rejected, then the catch will run. So what we can do is, we can just say get user. Now we know that this get user, we can call the functions like this, get post. But we know that this will not work. This is not a good pattern. So that's why we use async await, and we can say await. We can say await. We can say await. So what this await does, see, it will not work if you're not using async. So it will go hand in hand. What this await does is, it will not move to the next line until and unless this promise is resolved. So it will not move to the next line. That is the power of await. It will not move to the next line if this get post is resolved, right? And finally, we can say console.log all data fetch. So this is a more cleaner approach. You can see that we get the same output. It is a more elegant way of writing asynchronous code. And you can also see, guys, it feels like synchronous. So the code, if you look on a high level overview, it feels like synchronous, but behind the scenes, we know that we are using await to stop the execution from moving it to the next line. Until unless this promise is resolved or rejected, it will not move to the next line. It will not move to the next line, right? So that is the idea. And this is the latest syntax that people use now. This is also a widely acceptable syntax. You will see in a lot of code bases. This is something that you should not do because it's hard to maintain, right? So I hope, guys, those who are working already, they must have a clear idea of why people are using async await and promises now. And this was the major thing. Any questions here? Anyone?
Then here no need to write the then keyword, right? Once it is resolved.
Yeah, you don't have to write it, because that's why you're using await.
Okay.
Okay.
That get post method, like suppose if we don't write like a return new promise normal function, if we write still if we use await, then will it work?
Hey guys, I'm audible. I think I was disconnected.
Yeah.
So I was saying, guys, what I want to remember is this particular part for today's lecture because this is important. This is the complex piece, and this is something that we will discuss again. But this is just to give you an overview. So practice out by writing with yourself. Do console log. Check the output. Right.
Yeah,
Try.
here I have one doubt. Like, suppose in that
Uh,
get post or get comments method, if we write normally, if we write like console.log and fetch comments like that, and if we use await, will it still work without returning the new promise?
Wait, where? No, if it's not returning a promise, then it will not work. Then it does not make any sense also, right? Why do you want, because it's already synchronous. Why we are using await is because we want get post only to run after get user gets finished.
Yeah.
Getting my point?
Yes. But we are not resolving once we get that resolve. We are not using that then, right? We are waiting, but we are not resolving.
Yeah. So that question was clear.
Yes.
Okay. Any other questions, guys, here or in this diagram? Let me share this link with you guys. So I've shared in the chat. Okay. So Usha, Rajiv, Narinthiran, Srilekha, Raksha, Azir, Diksha,
No
guys, any
questions, sir.
questions? So these are a little bit of complex things, guys. In JavaScript, the people are already working with this. They already know that, right? It's just a matter of how much syntax that you write and how much you understand these boxes and everything, right? So it all boils down to the call stack, the event loop, and the callback queue. So when we'll study promises tomorrow, we will see the syntax. We'll also see that there is one more queue that I am yet to introduce, and we'll see that tomorrow. Okay. So if you have any questions, you can ask. Meanwhile, I'll just publish the code.
Sahil, one doubt.
Yeah.
We won't have any problem like that um, that health thing. There won't be any problem in await, is it?
What do you mean by problem?
Like we will, if we have a nested callbacks, we will be facing like
In await, there is no callback, no nested anything, right? It is
okay.
just await keyword, and unless and until that part is resolved, it will not move to the next line. That's it.
But before the like before await, we had this dot then right. There also we will have a um, this.
So if you have a nested dot,
Mhm.
then it is a problem,
Okay,
because
but
then
in
it will
await
be a
we don't have.
promise hell. But in await, you cannot have, right, because you are not passing any callbacks at all.
Okay, it will execute only after executing those lines.
Yeah. So I'll bring up some examples tomorrow. Let's cover that in detail. But if you got the idea that how we move from callbacks to promises to async await, I think that's fine for now.
Okay.
Focus more today on the event loop part.
Okay, thank you.
Okay, we'll cover that. We can take up that questions tomorrow as well once we have the syntax idea. So guys, I've shared the GitHub link as well. Okay. If no questions, we can end the session. Let's meet tomorrow and practice this out, guys, please. We'll take one more day to understand this part. Okay. So thanks, guys. Let's meet tomorrow. Have a great day.